Hello, you are highly welcome. In today's tutorial, we are going to be solving this. This is calculus, okay, and we are asked to find the dy dx for this function here. So now this function is implicit function, and you know how we solve implicit function, okay? But I want to use another method. I am tired of using implicit. It's a joke. But let's say I'm tired of using implicit function. For those that have done calculus to some extent, okay, you appreciate this and see wonder in mathematics. Now, what I'm going to do here is that I want you to know that if you want to do this, I can have this to be dy dx can be negative fx. That is partial derivative. That's why I said it's for those in higher classes. So partial derivative of x divided by partial derivative of y. So if you can find the partial derivative of x and the partial derivative of what? Of y, you're going to know what is dy dx is. Now here, this is what? This is our function. This is where we are coming. Okay, I want you to keep this one. Now we have our function x to the power of 3 plus 2xy squared. Now this one, we are going to take it to the left hand side. We're going to be having sine y, and this will be 0. Do you understand now? So you can see now that this one here is like f of x comma y, because we are seeing function of x and y there. So now what we are going to do, we're going to look for the partial derivative of x. This is written like this. The partial derivative of x is going to be, because this is f, this function, okay, the partial derivative of x with respect to x, because this is the partial derivative. Now what we are going to do here is that to get this one, we are going to differentiate. What we need to do is that if you are differentiating x, you differentiate it normal, okay, and treat y as constant. Are you getting it now? You treat y as what? As constant. Now this one is going to be differentiating with this. We're going to be having 3x squared, okay. Now differentiating this one here, you are going to differentiate x. This is going to be plus 2, okay, multiply by 1, okay, then treat this as constant. We have 2y squared. Now we have sine y here. This sine y here, I said treat it as constant, so that was going to be 0. So we have what? We have this, and this partial derivative of x to be 3x squared plus 2y squared. So partial derivative of x is 3x squared plus 2y squared. Now we look for the partial derivative of y. So this is going to be for y here. Let's look at y here. So since we have purely function of x here, this one return to 0 because we are differentiating with respect to x. Now here we are going to have what? Because we want to differentiate y, okay, then we pick 2x as what? As constant. So if we are differentiating these two, we multiply these two, we have 4x, then we have what? Y, okay, and here is going to be minus what? Minus cos y, because if you are differentiating sine y, we're going to be having cos y. So we have f partial derivative of x to be this, and this to be this. Now the next thing we are going to do is now to plug in these two values into what? Into this star. So coming to this star, from star, dy dx will now be negative 3x squared plus y squared. That is our partial derivative of x divided by, for this, 4xy minus cos y, okay. Then we're going to have dy dx to be equals. Now if you don't want this to be here, this negative side to be here, you can bring it down like having 3x squared plus y squared all over. This minus will affect this minus, is we change to cos y. Then this will affect this one, if we change to minus 4xy, and we have this. So now if you want to know whether we are right or not, you can simply use the method of implicit function, okay, to solve and see whether you are going to have this. But if you know that taking this minus here will give you another problem, just leave your answer here. That is the same thing. Do you understand now? So now check this and use this, okay, formula to solve more implicit function, you'll see that you're going to what? You're going to have this to be this. Thank you so much for watching. If you enjoyed this class, please kindly share to your friends so they can learn from it. Thank you so much for watching. Bye bye.